Nice to have you here. Thanks to the organizers for letting me have this stage here. Most of the time, actually, I will be talking about coffee. And I'm hoping that you can make the transfer to software probably on your own, but probably I have to work a bit on that. When I prepared that presentation, I asked the artificial intelligence to draw some images, to draw one with a combination of quality coffee and the Eiffel Tower. You have to decide if you like that or not. I'll be using this 45 minutes. I think I will be using all of the time, and to give you an impression what's going to come, I tried a too long don't read slide. It's QR to QS. And you see here a long winding road leading to hopefully a better world, a better situation. QR are quality requirements, and QS is the quality of your system. And I will be talking about the necessity to get the quality R in the bottom, the quality requirements right, so you can build the right system. And if you have no idea what the quality requirements are, so what is a good coffee, you will never be able to prepare one, because quality is a very, very difficult beast to tackle, because the term quality is so implicit, and everybody here in the room will have their own ideas what makes up a good coffee or makes up a good product. And that's what I try to clarify in most of my talk. And if there is some time left in the end, we're going to talk about how to achieve that in software. But I'm pretty optimistic that you all know how to do that. I am Gernot. In my spare time, I do conference talks, and in my professional time, I consult clients on software architecture. And in the rest, I write books and whatever. Talking about books, how do you order your books at home? I'm pretty sure you all have some technical books, some programming books, but I'm pretty sure that at least a few of you will also have some fiction books. And how do you structure the books at home? We at home, for a very long time, we had two shelves in two different rooms. One for the technical books. My wife is also from IT, so we had a mutual shelf with all the technical books in it. And we had one shelf for this Harry Potter's and what else we have in fiction. And then that happened. And we had a problem, because we didn't know where to solve the Phoenix project. It's a fictional story. It's a good fictional story, actually. And it's a technical book. And a friend of mine suggested buy a second one, which my wife, who is my finance minister, denied. So we didn't buy a second one. But everybody of you has an idea on how to solve that problem, because in web technology, we invented tags and labels. And that one will become important when we talk about quality and quality requirements a bit later on. Because tags and labels are a well-known method, a well-known strategy of handling large portions of information, giving them a structure, but not a strict hierarchy. So we are talking about quality here. And what makes a good coffee? Actually, I had no good coffee in the morning. I didn't want to try the hotel coffee machine. And I'm not sure whether I should call this Nespresso stuff good. Good coffee is for IT people a basic requirement to work. Actually, I also drink tea, but what makes up a good coffee? Good coffee is a translation, pragmatic translation of the probably more formal term, the quality of coffee. But what makes up this quality? So we could come up with some ideas. We could ask for, where do the beans come from which part of the world? Have they been grown biologically or without herbicides? Is it sugar? Is it sweetened? Has it a caramel or a chocolate taste? Is cow milk in it, soy milk in it, oat milk in it? Is it an Americano, espresso, un petit noir? Whatever your impression is, it's a subjective definition of what's quality. So if I would ask anybody of you to prepare a good coffee, you would have to guess what I mean by the quality of coffee. And yeah, let's say I take this analogy from real world, but actually we have the same problem we have with the quality of coffee with all other products. And very often when we talk about quality in software, we refer to system properties. The thing is, every system has certain properties. The definition of quality is the product properties that meets or exceeds stakeholder expectations, blah, blah. It's very abstract. So if I give you this definition and I tell you, please prepare a coffee compliant to this definition, you would still not exactly know what to do. You'll probably push the Nespresso button and would see what happens. So, when we talk about quality, we have to be careful with product properties. So we have to talk about product properties, but in a bit more detail. As I said, every product has certain properties. You see code on the left, and you see a product on the right, a technical product, a car, and they all have certain properties. I talk a bit more about software today, so I skip the car. This software has some modularity. So it has the property of modularity. Actually, when you see the formatting, it's not much. It has some performance. We don't know what performance it has, but it will have some. Maybe in your definition, not a good one, but it'll surely have one. It'll have some flexibility. Again, we currently don't know what kind of flexibility. Now, these are all properties, inherent properties of any part of code. So any code you write has a certain quality, has a certain number of properties. We don't know to what amount we have performance, modularity, security, and so on. As I said, I'm going to talk about coffee. And to explain what I think is a good coffee, I'll have to use a French product, the croissant. The French croissant is more or less butter, with a little bit of other stuff in it, mixed in it. So the best croissant tastes like butter, and it's a very, very nice taste from my point of view. And I also like the taste of coffee. I like not the pure Arabica beans. I like a mixture, but that's another thing. So why not combine these two tastes, the taste of butter and the taste of coffee? And actually, people have done that. They call that bulletproof. Anybody of you tried bulletproof coffee? You heard of that before? I actually drink that stuff. It's butter mixed in coffee. I'll show you. You see, I really drank it. This cup of coffee, bulletproof coffee, has a very high level of energy in it because there's butter in it. And Saturday morning is the traditional sports morning in my family because my wife is a indoor cycling and whatever trainer. She has a day job in IT, but on the weekends she mutates, and I have to go with her. I really like to do that, but I don't like to eat a lot of carbohydrates in the morning, but I need some energy. So I drink bulletproof coffee. That gives me a lot of energy, believe me. Whenever you go to a class with my wife, you will see that you need this energy. And from my point of view, it tastes really good. So if I ask you to make a good coffee, there must be some butter in it. And until now, people told me after I published this video on Instagram, probably I should never go to Italy again because they will catch me at the border and throw me in jail. But that's another story. I'm in France here. Nobody would have guessed that butter should go into coffee. So the property of the amount of butter content for all of you would have been 0. Do I guess right? Nobody will throw butter in the coffee. Actually, I also throw cocoa fat in the cocoa oil in the coffee as a second ingredient giving energy and taste. And now, to make this a bit more systematic, we could collect all kinds of the quality of my presentation software. We could collect all kinds of attributes that are somehow connected to coffee and write them all down. And I call that dimension 1, the collection of all thinkable properties coffee might have. That's taste. Most of you will say taste as the first one. It could be some add-ons, the kind of preparation, the way it's produced, and so on and so on. And if we brainstorm about coffee properties, we'll come up with a lot of ideas, and we could structure these ideas in a way typical software quality models are structured. This model is completely fake. So although I gave it a hypothetical ISO number, it's fake, obviously. But we could do that. And that's what the ISO standard did for software. They collected attributes, properties that might be interesting for software. By the way, butter content is not one of these properties here. So the ISO forgot butter in their coffee quality model. Now, to make it a bit more precise, instead of just collecting these properties, we could start defining the properties. So come up with some textual definition. What is a taste? Degree of olfactory stimulation under specified conditions. Do you now know what to do? When I ask you, I want tasty coffee? No, you don't. But the definition sounds scientifically. What is the direct taste? The degree of immediate taste stimulation when consuming a defined quantity at a defined temperature. Still no idea what to do. Welcome to the world of ISO quality definitions. No idea what to do. The issue is we have all these properties, but we don't know the extent to what these properties are required. So the extent of cocoa or butter or whatever. Let's make up a second dimension into that model. The dimension 1, the first dimension was we numbered, we collected all the potential property attributes, quality attributes or properties. The dimension 2 numbers enumerates the values, the potential values. So we could, for the taste, collect all the tastes we can come up with. Actually, the room on the slide is limited, so I just picked a few. We could collect all the add-ons we come up with for coffee production. You see on the slide that a few of these quality attributes or properties can be measured with a number, like temperature. So you can give me a degree in Celsius or Fahrenheit on how hot or cold you want your coffee to be. You can enumerate the prices. So from close to 0 per cup. Actually, I spent an hour yesterday in a very fancy Parisian brewery, a coffee brewery with a barista. And I paid, I think, €8 for a specialty espresso. Most expensive espresso, except for the ones in Switzerland, but most expensive espresso I ever had in France. A very, very tasty, very fruity taste. The barista needed 6 or 8 minutes to prepare that. So it was worth the money, but it probably exceeds the day-to-day espresso budget you will have for yourself. Now, we have a two-dimensional model of quality, and now I am able to better define what I think is a quality coffee by giving you the coordinates, what kind of property is interesting for me and to what extent it's interesting. So now the requirements are way more clear than if I just said, I want a nice taste and I want nice beans, whatever. So I can pinpoint, I want the taste to a bit like cocoa, I want butter as an add-on, and so on and so on. I gave this to the AI. That was AI made from it. That's not me. So I still like it. Probably there is too much butter in the coffee and it's flowing over, and that's why the people are so, yeah. But the problem is not solved because I'm not the only one having requirements for a product. And if you ask different people for their quality requirements, they might come up with very strange ideas you haven't even guessed. Let's take my kids. They are grown up at 20-something, and they are practicing sports like hell. They should better study, but they don't like to study, they like sports. And they like ultra-high caffeine levels. They don't care about the taste. They want more caffeine in it, more bang for the buck. And they have beans with a trifold level of caffeine compared to regular beans. And they gave me these beans for Christmas. I didn't believe that. So I prepared a regular coffee with these special beans on the second day of Christmas. And I was awake for 3 days, I think, could sleep. So this is a requirement I don't have personally. There might be other stakeholders, like a barista, the one preparing the coffee, and probably these guys are interested in a coffee machine that they can operate without hurting their back. This is factually a problem I have in one of my favorite coffee shops in Cologne, where I come from, where the owner of the shop put the machine at a very strange location, and the lady operating the machine, she has to move forward, turn her body to reach the machine. And you do that 3 times a day, and your back hurts. And her requirement is a different one. Now you can say, oh, that is not connected to coffee at all, but she's an important stakeholder. And if she pays your bill, she can ask you for nearly anything. And it might be the position of a machine. And it might be that your management asks for how much does it cost, what is the time to market, how fast can you produce the coffee. And then it's no use to negotiate or try to negotiate is the time to market a property of the coffee itself, or is it a property of the production process? You have to comply. So we in IT, we have to collect the largest possible number of potential properties of the system we have to produce and comply to those, unless they are illegal or whatever, but I think you know what I mean. So our two-dimensional model of properties and qualities is okay, but we need a third dimension with stakeholders. We skip the stakeholder part for now. Clever people have collected potential properties for software for ages. And usually I don't like animated slides. I just wanted to prove that I can produce animated slides. I asked the AI how to produce an animated slide and copy the instruction, and here you see what's going on. It's a lot of properties that are potentially relevant for software. And people cleverer than me have started collecting these properties since the 70s of the last century. I won't go in the details of the history of these quality models. It's interesting for some people. I brought two of these models as examples. One is from a book I really, really like for various reasons, Software Architecture in Practice. It's written by guys from the Software Engineering Institute, the Carnegie Mellon University in the US. And one reason I like this book is because it's really pragmatic. Although the SEI is an institution doing large-scale IT projects, they have a pragmatic approach to quality, and they give various hints on how to achieve the qualities. Their collection of 9 groups of such properties is somewhat special, but I like it. So it's a great idea. The other model I want to show you is the ISO. The International Standards Organization, ISO, publishes, what the name implies, standard papers. And they have a standard on software product quality. It's the ISO 25 something. Anybody heard of that? Anybody read one of these? That's what I guessed. Because it's boring stuff to read the standards. One issue I have, I read the standard, at least I read part of the standard. I have to do for my job. I have clients, and I'm consulting companies where the executives have read the standards, or at least they tell me they have read the standards. One problem I have with this standard, it's about 1,000 pages of boring PDF stuff, and after reading it, I still didn't know what to do. The other problem I have, you have to invest about 2,600 euro to get the PDFs that are actually very boring to read, and I don't recommend doing that. There is 2 things these ISO guys have done really, really well. One is collecting a few of these attributes as a proposal of what could be interesting properties of software. They have structured this in a tree-like way, and they have defined the terms. So that's way better than having nothing, is using this standard. This tree-like visualization and the definitions are free of charge. So grab it until they put a price tag on it. It's freely available on the website of the ISO. And as I said, it's better than having nothing. But still, you won't have any idea what is exactly meant. I will give you an example. I copied their definition of flexibility. You probably have your own impression what is flexible. Maybe your partners or kids or yourself, you practice yoga. And that's a way of interpreting flexibility. I practice yoga, so usually I can touch the ground with my hands, but I have a mic attached to my belt, so I won't show you. The capability of a product to be adapted to changes in its requirements, contexts of use or system environment. Thank you, ISO. Now I know exactly what to do. Now I know exactly what people expect when they say flexibility. Can I change the layout, the color theme at runtime? In your favorite browser, I hope it's Firefox, not Chrome. In your favorite browser, you can put color themes to work, and you make it a dark Firefox or a light Firefox or a French Firefox or whatever. I really like changing the appearance of an IT system at runtime. I'm using VS Code as my favorite, one of my two favorite editors, and I can change the color theme. And that's, for me, that's flexibility. But I'm not the only one. The product owner, I'm not product owner, I'm a developer and architect. The product owner asks, can I flexibly get new features? That's a different thing than changing the UI theme or layout. Your ops guys, your DevOps guys will probably ask for, oh, can I change from Amazon Cloud to Google Cloud to Heroku Cloud to Fly.io, whatever. So it's a different interpretation of flexibility. And the management will want to use the software after the large reorganization they plan for the upcoming year. So one term, flexibility, one ISO definition, and four completely different interpretations. And we still don't know what to do. So this is not enough as quality requirements. Let's try to be more specific. So let's go for a solution. I have to give you a little context. I was consulting a German tech company that produces coffee machines and other stuff. And the energy of this, they have a configuration, they have a user interface where you can configure, for example, the brew temperature, the brew duration, and whatever. And these configuration settings are buffered by some electrical energy with an onboard battery. During COVID, they couldn't get the batteries. The batteries were stuck in any ship in some Egyptian channel, and so they had the coffee machines, but no batteries, and couldn't sell the coffee machines. That was a real drama, because they lost a lot of money when the coffee machines piled up and they couldn't sell. You can understand that, I'm quite sure. So they overhauled their quality requirements for that system. And they said, the system, the next generation of the system, shall be compatible with battery models, not just by our one original provider, but with the 5 preferred battery suppliers. That's flexibility. Now, that's one interpretation, one very specific interpretation of quality. But now, as an engineer, you know what to do. I have to change the board so that not only the measurements of a single battery is suitable, but I have to look at other suppliers and change the, I cannot explain that so well because I don't build boards, but you can imagine these little very specific batteries are no standard batteries, but they all have different electrical and physical properties. So a definition of flexibility like that is highly usable for us engineers. And it's way better to have such a definition than just say, I want flexibility. Do you remember I asked you for your books at the beginning of the talk? The technical and the fictional books. The ISO standard has a very strict order, a hierarchy of these quality properties. So let's take the requirement. A user can configure the UI at runtime. It's a refinement of a flexibility requirement, but it's also a usability requirement. So it's both. Will you copy and paste it and have two requirements now? Or will you give it labels? The ISO, I tried to contact the ISO to propose labels or tags instead of the fixed hierarchy, but nobody answered my email. Probably it's because I wrote the email only a year ago, and the iteration cycles in ISO are 11 years. So I'm still waiting for the answer. But I suggest that you refrain from using a strict hierarchy in qualities. We'll come to that a bit later. So I complained about this ISO stuff and the unsuitability of these definitions for a while, but I am an active open source contributor. I am the founder of an open source architecture framework you are probably not interested in, but I am used to acting and not only whining. So what I did, I created an open source quality model collecting the dimension 1, all the attributes or properties. And when I started that, I wondered, because in the ISO standard, in the official ISO standard, that's more than 25 years old, so it's not a new standard, it's quite an old one. Or this ISO standard collects about 40 such attributes. And time to market is missing, and deployability and all the cloud stuff is missing, and AI stuff is missing. My goal was to collect some more. So I researched a bit, I consulted Wikipedia, and I came up with more than 150. So in the number of attributes, this ARC42 quality model is already leading. So the chances are high that the properties you have in mind are contained in there. If not, open a pull request and let me know. And the other thing is, to become better than the ISO, I wanted to give you examples of how can you formulate such a requirement and not just give you an abstract definition. So I collected examples of very specific requirements, like this battery provider requirement or this exchangeable UI requirement. Because by having an example, you can transfer the example to your own domain, exchange some keywords, and you have a baseline for your specific quality requirements. This is my goal. Have a nearly complete collection of dimension 1 and have this dimension 2, the potential values, by example. It's a public website. It's a subdomain of ARC42. I'm afraid it's all written in English. I have 10 minutes left. Thank you. This is the major thing I wanna give you is this hint. If you want specific quality requirements, there is a free and open source collection where you can have a look, that you can show to your stakeholders, and that you can navigate quite easily. One way to navigate is by having an entry point with these 8 top-level properties, or you can take this 150-something lower-level qualities. So it's navigable. This is an overview of a few of the examples, so we don't have time to read it. I will give you another one. The system must be able to process 1,000 sensor inputs per minute. Oh, you don't have a sensor. You probably have a user. Your system must be able to process 1,000 user inputs per whatever. You don't think in minutes, you think in seconds. Okay, exchange a term in the example and you're done. About accuracy. Yes, I need accurate calculation. Hey boss, what do you mean by accurate? It's 2-digit after the comma, it's 8 digits after the comma. Last week I had a conversation with a physicist working at CERN in Geneva, and they need 14 digits after the comma. 14. And this typical 2-digit calculations is simply not enough for these guys. So exchange some terms or some numbers in the examples and you're done. Handle sudden increase in traffic, a reliability or scalability requirements. We don't read that here. As I said in the beginning, we are using tags or labels to label these requirements so you can easily find them. Even if you don't think on usability, but on flexibility, you will be able to navigate to the examples you can use. All right. The whole thing is done. I call myself a practitioner. I have to deliver working software. So I need things that help me delivering working software. And I always struggled with non-existing or bad quality requirements. And this open source, freely available approach helped my projects, helped me in my projects and helped a lot of my clients. This is a fairly young project. It's about a year and a half since I started that. I had a lot of contributions by the community that helped that came up with the properties I haven't even heard of, especially in the AI world. But I encourage you, give it a try. If you have bad requirements in your project, I'm sure that one will help you get better. My goal was to become nearly complete in dimension 1. Currently, I have over 150. I have about 10 to 15 in my personal to-do list. So I think that's good enough. Since about half a year, nobody has complained about any missing attribute. So give it a try, challenge me. I'm not satisfied with the number of examples because certain of these properties I mentioned currently don't have an example. So I still need some work to do. As I said, pull requests are welcome. So if you can use this model in your practical work, probably give something back to open source. And that's my take on getting the quality requirements right. Because if you don't get the requirements right, you will never be able to prepare a coffee your stakeholder will like. So you have to have this foundation. From there, the rest is, let's call it quality-driven architecture, but if the foundation is solid, so if your requirements are okay, it's just regular project work. You and your team, you have experience enough, if the requirements are clear, on how to transform the board to make it fit for 5 different battery types. That's not the issue. And yeah, you can collect ideas, approaches, whatever, based on the specific requirements. That's fairly easy. No, it's not easy. It's work. It has to be done. But it's not as hard as trying to prepare a product when you don't know what your stakeholders are expecting. And I come back to this nice book, because the nice book contains a lot of ideas on how to achieve the requirements. So what these guys did, they collected approaches, tactics, patterns, ideas on how to achieve. Okay, they have a probably limited collection of such properties, but still it's the best collection I could come up with, I could find. We are trying to do that in this ARC42 quality model, but that's for the upcoming release, not for now. We are actively working with research institutions, with at least a few universities that are involved in requirements engineering, systematic requirements engineering, to get a better grip. We are collecting feedback from projects, and we are trying to spread the word. And yeah, that's my take. Clarify what is good enough for your system, and the rest is just project work. Thank you so much for listening. And I think we have time for some questions, in case you have some. Oh.
So what's the difference between quality requirements and just requirements or technical requirements?
Actually, nothing. There is, in the history of requirements engineering, we had a difference between functional requirements and quality or non-functional. And that's completely crazy to do that, because if your smartphone is not able to phone, you won't call it a good quality product. Even if it has 300 days of battery, whatever. It's not interesting. Functionality is part of quality. So from my take, I would throw everything into one basket and never talk about, is it this category or that category? Is it a constraint or requirement? Put it all there, because you have to deliver a system compliant to everything in the basket.
How do you know where is the limit of over-engineering?
There is a risk of over-engineering. As a software architect, I can estimate by experience only. So if I talk to stakeholders and they call for more and more and more, the price is getting higher. I will have to tell my product owner, yes, we can deliver all these features and all these qualities and all this performance, but the price is going to grow. And if you have an experienced product owner who's worth her or his money, then they will tell you, oh, sorry, we cannot do all that. And do it iteratively, talk to your team, and explicitly care for not over-engineering. Then things work out, I'm sure.
Thank you.
What is missing in DDD related to this approach of quality?
Actually, in the original domain-driven design book by Eric Evans, neither performance nor scalability, elasticity, accuracy, whatever, all of these quality attributes are left out. That doesn't make DDD any worse. So it's a great method of structuring your system, but you still need to care about performance. And I call this domain-driven on one hand and quality-driven on the other hand the perfect match. Because you need both. You need to structure your application by your domain structure, domain functions and data, but you still, as I said, need to care for how do I get this performance right. So you need both.
By my experience, I think we focus a lot on features, on functional, and we neglect
yes, that's
quality.
That's why I suggest to add quality. Thinking of qualities to your domain engineering. And my colleague Michael, who will be talking in some minutes, a few rooms up there, he's a very active member of the domain-driven DDD community. He is a founder of the DDD gang. And he brought quality to the DDD discussion in several projects years ago. And because it's missing in the books, in the previous book. So in Vlad's book, it's in there. So it got better. Do we have time for one more?
Last one.
Okay, last one. The boss. Yeah. Actually, I'm very unhappy with the SonarQube notion of quality because they are so incredibly inspecific. They write quality, but they use very, very specific metrics. And if you have a very high rating in SonarQube quality, it can be awfully slow at runtime. But your quality metrics are high. So please have a broader picture, be specific what you really need, and part of that can be checked with SonarQube or ArcUnit or whatever tooling, but only part of it. And don't give these SonarQube numbers to your management. I'll be available on the floors for a while. Thank you very much, and give me a feedback or a pull request whenever you found a chance to use it. Have a nice day.